Good morning. Today we are going to discuss operation principle of one of the semiconductor memory called dynamic RAM. So before we are going to discuss about the basic principle of dynamic RAM operation, I would like to introduce to myself. I am Dr. J. Prasad, working as an assistant professor in the Department of Electronics and Communication Engineering, KPR Institute of Engineering and Technology. Today's presentation deal with these three content. The first content is a semiconductor memory general architecture. With respect to the general architecture, what we are going to discuss, I am going to explain how the read and write operation carried out on dynamic RAM memory with one transistor configuration and three transistor configuration. The general structure of semiconductor memory, it consists of 2 to the power of n number of column line and 2 to the power of n number of row line, and each row and column line is interconnected through a memory cell. So this black box, it indicate to be a memory cell which is then responsible for interconnecting of row line and column line. So based on the type of memory cell, semiconductor memory, further it will be classified into two types, static RAM and dynamic RAM. It may be in a static RAM or dynamic RAM. The basic principle of any kind of a semiconductor memory, it will be do either read operation or write operation. Then what do you mean by a read and write operation is, if information stored in any memory, if it is transferred to some external device, then it is called to be a read operation. Then what do you mean by write operation means, if any information communicated from external device to memory device, then it is called to be an write operation. Then we might have a question, what is the function of row decoder address and column decoder address in a semiconductor memory? And say for example, this is a particular memory. Over this particular memory, if I want to do either read operation or write operation, first I need to be identify the address location of that corresponding memory. For that purpose only, we have a row decoder and column decoder. Row decoder identify the row address and column decoder identify the column address. With respect to the address identified by row decoder and column decoder only, we are going to perform either read or write operation on the corresponding memory. As I explained in my previous slide, based on the type of memory cell, semiconductor memory broadly classified into two types, namely static RAM and dynamic RAM. Like in static RAM, the type of memory cell is called to be a bistable circuit, probably latch, and whereas in a dynamic RAM, the memory cell, it is made up of capacitor. So in what basis the read and write operation is performed on dynamic RAM is the amount of charge available in the capacitor, memory device, memory cell, the read and write operation will be performed. Say for example, let me consider one transistor dynamic RAM cell configuration. Here we can see that the C, it indicate to be in memory cell, and CC, it is called to be in column capacitance, and M1, it is in a pass transistor. That M1 pass transistor is the responsible for to do read and write operation on dynamic RAM memory. So with respect to read and write control input, the transistor M1 will be either comes to be an on condition or off condition. Then what do you mean by read operation in dynamic RAM memory is, if the energy stored in a capacitor, if it is transferred to a bit line, then it is called to be an read operation. If the energy stored in a bit line, if it is transferred to a capacitance, then it is called to be an write operation. So from this discussion, what I am trying to conclude is, in dynamic RAM memory, read and write operation will be performed based on the amount of charge carrier sharing between these two capacitance only. Read and write operation will be performed. The detailed operation of one transistor dynamic RAM cell I will explain in my forthcoming slide. This is same circuit what I explained in my previous slide, and here I am going to explain more deeply how read and write operation performed on one transistor dynamic RAM memory cell. Kindly look at the circuit diagram. It consists of capacitance. So probably it is memory cell. It's connected to NMOS pass transistor M1. It is consist of a data line, and CC it indicate to be an column capacitance. Like in write operation, what it means is the information transfer from bit line to capacitance, it is called to be an write operation. If energy transfer from capacitance to bit line, it is called to be an write operation. So first let me explain you what do you mean by a write operation. The write operation performed with respect to the transistor M1. So since it is an NMOS pass transistor, the control signal is supposed to be equal to 1, so that it become an on condition. So since it is in a write operation, I activate R equal to 1, W equal to 1, R equal to 0. So the transistor M1 will be connected. If data input equal to 1, the information stored in that column capacitance, since its data unit equal to 1, the capacitance is stored in a maximum value of VDD, probably 5 volt. Since transistor M1 is on condition, that 5 volt will be through transistor M1, it is connected to capacitance. Probably store across voltage across the capacitor will be 5 volt. It means that it hold the value of logic 1. So this is called to be an write 1 operation. And for write 0 operation, the initial condition the capacitor will be approximately equal to 5 volt. Since the data unit equal to 0, the capacitor started to discharge. It means that the amount of energy stored in a capacitor goes to be in a decreases. So this is called to be a write 0 operation. Then coming to read operation, how it will be performed is the amount of the capacitance between CC and C, the amount of capacitance between CC and C only, the read operation will be performed. So as I explained, what is read operation means, the information shared from memory cell to bit line, it is called to be an read operation. Okay, say for example, in read operation, actually we have a column capacitance. It is column capacitance bring to pre-charge level VDD by 2. Okay, so actually how that read operation will be performed as transistor. For read operation, just I am going to select R equal to 1, write operation, control unit will be 0. So the transistor M1 become an on condition. In read operation, while we comparing the amount of charge, while we are going to comparing the amount of voltage between CC to C capacitance, the CC has a maximum value. So due to charge sharing problem, the amount of charge available in the capacitance through transistor, it started to discharge through bit line. So the information transfer from capacitance to bit line, it is called to be a read operation. So this is how read and write operations are performed in dynamic RAM memory. This is overall configuration of 3 transistor dynamic RAM memory cell. So I will explain you one by one how pre-charge operation, read, write operation will be performed in my forthcoming slide. So these are the different operations on 3 transistor dynamic RAM memory. First, let me start with a pre-charge operation. In pre-charge operation, what it tells is, like in overall architecture, it consists of n number of transistor. Out of n number of transistor, we need to be switch on transistor MP1 and MP2, and rest of all transistor we need to be keep off condition. So for that purpose, I select write select equal to 0, so that transistor M1 become an off condition, M2 become an off condition. Also I am going to select row select equal to 0, so that transistor M3 will be 0. Okay, so basically what is the main objective of a pre-charge operation is with the help of transistor MP1 and MP2, you are going to set the initial voltage, that you are going to set the initial voltage across these two column capacitance. So this is called to be an pre-charge operation. Then coming to write operation on 3 transistor dynamic RAM configuration. For performing of write operation, I need to be select write select equal to 1 and read select equal to 0, and like column capacitance CC, C naught C, it is comes to be in a pre-charge level. With help of MP1 and MP2 transistor, we are going to set the initial condition in CC and C naught C. Okay. Since write select equal to 1, the transistor M1 become an on condition and M3 become an off condition. Okay, that C it is called to be an memory cell. Since the transistor M1 become an on condition, the data line 0, its corresponding voltage level will be, VDD level voltage will be, it is stored across a capacitance C through transistor M1. So this is called to be an write 1 operation on 3 transistor dynamic RAM configuration. Next, read 1 operation. So as we discussed in previous slide, like in a read operation, the information, energy will be transferred from memory cell to bit line. So since it is in a read 1 operation, I keep row select equal to control signal equal to 1 and write select equal to 0, so that transistor M1 become an off condition and initial voltage across the memory cell will be VDD. So the transistor M2 become an on condition. Since row select equal to 1, M3 become an on condition. So through transistor M2 and M3, the amount of the amount of charge carrier available in the memory cell capacitor C, it will be reaches to bit line. So this is called to be an read 1 operation. Then coming to write 0 operation, the same principle. So since it is in a write operation, I select write select equal to 1 and row select equal to 0. So since row select equal to 0, M3 become an off condition, initial voltage in the capacitor will be 0, so transistor M2 become an off condition. So the column data equal to 1, so the column capacitance CC hold the value of 1. So since the transistor M1 on condition, the amount of energy stored in the column capacitance, it is transferred to capacitance C. So it is called to be an write 0 operation. For read 0 operation, and select row select equal to 1 and write select equal to 0. So the transistor M1 become an off condition, initial voltage across the capacitor memory cell will be 0, so M2 become an off condition, write row select equal to 1, so M3 become an on condition. So the voltage will be comparing the voltage drop across the capacitor C naught C and capacitance will be compared. So it is stored across 0 volt. So the capacitance amount of energy stored in a capacitance will be started to discharge through bit line. So this is called to be a read 0 operation. Thank you.